Okay, here we're looking at a computer-generated pump performance curve. And you can see that it's got the maximum diameter impeller and the minimum diameter impeller signified by those two lines. And we can actually trim the pump impeller, providing it's made of cast iron or cast steel, to any diameter between those limits. We're not restricted to any individual diameter. And you can see here that we've got our efficiency zones. This is at the best efficiency point of 80%. We've got 75 as the next zone, 70 as the next zone. And we really want to be operating as close to best efficiency point as we can. If we're given a duty, and that's shown by this little tick here, that duty is falling in the best efficiency zone, and it's to the left of best efficiency, where we've got a 25% margin for error. If it was falling on the right-hand side, we'd only have a 10% margin for error to be operating in the preferred operating zone. If we look here, we've got dotted lines which show us the power absorbed. And at this point, you can see that the power absorbed, the amount of power we need up the motor shaft, is between 15 and 18.5 kilowatts. But we can't size our electric motor between 15 and 18.5 kilowatts. We have to go to the power at the end of the curve. And the power at the end of the curve is between 22 and 30 kilowatts. So if we want a non-overloading motor, even though we only need about 18 kilowatts for the duty, we would size the motor for 30 kilowatts to give us a non-overloading characteristic. On this curve, we have generated a theoretical system curve, but this system curve that we've generated is for a recirculating system. In other words, our system resistance is zero static. So our starting point for this curve is here. We then follow a square law curve through the duty point, assuming that our client has calculated that duty correctly, and we can see what would happen, theoretically, if we didn't trim that impeller. And we would move out to this point, so our pump would actually overperform. So to bring it back to this point, we would slow the pump down using the affinity laws, and we would come to a speed not of 1450, but maybe 1390, which will give us an exact match to that duty. But it means that we can tune the pump's performance using a variable speed drive to give us exactly the operation point that suits us best.